In 6.1, we're to state the quantity that is not conserved in an inelastic collision. Well, that is kinetic energy. In 6.2, we're to show that the speed of the joined trucks after the collision is about 0.3 meters per second. Well, by conservation of linear momentum, we have 2.8 times 16,000 plus minus 3.1 times 12,000, that's our initial momentum, must equal the combined mass of 16,000 plus 12,000 times V. So V is equal to 2.8 times 16,000 plus 3.1 minus 3.1, sorry, times 12,000 all over 16,000 plus 12,000. This gives 0.27 meters per second, which is about 0.3 meters per second as required. In 6.3, we're asked to calculate the impulse acting on each truck during the collision, giving an appropriate unit. Well, impulse is equal to change in momentum, which is m delta v, assuming the mass doesn't change. And it will be the same for both trucks. So we can just work out the change in momentum for one of the trucks. So I'm going to have a mass of 16,000 times the change in momentum is the change in speed, sorry. The initial speed was 2.8 minus the final speed of 0.27. This gives an impulse of 4480 units of Newton seconds. Whoops, Newton seconds. Or we can have 4.05 times 10 to the 4 Newton seconds. Or we could use kilogram meter per second. In 6.4, we're to explain without a calculation how the motion of the trucks after the collision will be different if the collision were perfectly elastic. Well, now the trucks would move in opposite directions. The momentum of B after the collision would have to be the same as the momentum of A before, and vice versa. To conserve momentum, we're conserving a quantity dependent on velocity, and to conserve kinetic energy, we're conserving a quantity dependent on velocity squared.